Hi, this is Roger from Kanka Labs. Today with two further promising battery testers or constant current loads that have arrived. You might know this one here from one of the last videos where I first of all had to repair it. And in the meantime also this cheaper one and smaller one here has arrived. So because I've explained some of the features of this one here already in the repair video, we'll first take a closer look at the smaller unit here. By the way, this one here is in the range of 10 euros or dollars, this one here. And this sells basically as they have it on the bottom, as a USB load. So it's mainly designed for testing USB power banks, USB chargers, etc. This one here sells a fully fledged constant current load, and of course you can already see from the size of the cooling fans, this one here goes, I think it's sold as 35 watt maximum power dissipation, while this one here, there are different models in eBay, between 100 and 150 watts, which might even be reasonably concerning this big CPU cooling fan. So nevertheless, I hope that one of them really serves my purpose. You might remember this small one here, which would have been ideal for my purpose to test single cell batteries between 1.25 volts and perhaps up to a maximum of 6 volts. This one would have been really ideal, small, cheap, and it has exactly the functionality that I need. This one is not a constant current source. It simply puts a load resistor onto your power source, onto your battery, and then measures current and voltage at the same time. So if only this would have been accurate, but sorry, the word accuracy for this thing is really not right. When the current goes, let's say, below 1 amp, the measurement result is totally out of range. The timing is totally wrong, so the internal timer is very inaccurate. So you can't use this thing. Perhaps these are a little bit more promising. So let's first of all take a look at this one and change the magnification or the zoom mode a little bit. So of course you don't get a manual with this one. You just have to find out anything by yourself. And the first thing you have to find out is where to put the external power on. And this is marked here as this power. So this is that you connect just with a micro USB connector to your PC or any other 5 volt source. Then this thing is powered up, and here we have a little LCD or perhaps even an organic LED display, don't know. With all the values it can measure: volts, amps, the time, watts, amp hours and watt hours, and of course in different modes. Let's see. Here it measures even D plus and D minus, apparently the voltage on the USB connectors, which we take a look at in another moment. Chinese symbols. Now here you have a lot of USB connectors or chargers, like here iPhone 5S, micro USB, type C USB, mini USB, and thank God you have two very small screw terminals, which we desperately need here. And here also for USB loads some USB connectors. But the first thing is, because this thing has not a Kelvin connection, a 4-wire Kelvin connection to the load, the watt and the watt hours display, you can forget about this, because you always have some voltage drop here on your connecting lines, so don't rely on that. The only thing that could be really accurate, sorry for the refocus time, would be the volts, the amps and the amp hours display. And I would be happy if even these would be accurately. We'll see in a few minutes. A little push button here for, if you push it long, then it resets. Because this thing, you could see it has reset the time. Because this thing stores the last value in internal EEPROM, and so you can continue your measurement even after an interruption. So that's quite nice, and just reset it with 2 seconds push of the only single push button here. What's quite interesting is I've already taken off the protecting, let's turn it around, the protective plastic cover here, so that's just for isolation from the ground. What can we see? We have 2 potentiometers where the set current is regulated with fine and coarse control. So apparently the constant current is not set digitally, but it's set simply with these 2 potentiometers in an analog way. So basically this is an analog constant current source, only the values are measured. And the main thing here is a Holtec controller. It's the, let me look it up, the HT66F018, and it has a few very nice features. A 12-bit ADC. The internal RC clock has an accuracy of 2% at room temperature, so that's quite good. And the internal reference, the bandgap reference, has a 3% accuracy. So all in all, we would expect a measurement accuracy in the range of a few percent, which is completely sufficient for a battery tester, a coulometer or amp hours meter, or however you want to call it. What else do we have? This is an EEPROM. I really don't know. It's a 24C32. If the internal flash memory is not sufficient for the firmware, or if they only store the last measurement value here, you could store this also in internal flash. So anyway, and if you remember the last video about the repair of the big constant current load, we have a very similar circuit. Here we again have the good old switching regulator, the MC35063A. This is the shunt resistor with 50 milliohms. R050 means 50 milliohms. What else do we have? So these are probably a few transistors. This is a, what is it, a 5-volt, a 3-volt linear regulator. So the 5-volt from the USB is regulated down to 3 volts for the microcontroller. And a few Schottky diodes like here, and I've seen some more somewhere around. Here, these are also Schottky protection diodes, probably for protecting it from reverse current or reverse voltages. This probably an op amp here, and so not much to see. And the main transistor is a TIP 122, which can withstand up to 5 amps current and 60 volts voltage and up to 65 watts, and it's screwed directly onto the cooling, the heatsink, and with the it might even be possible to dissipate 35 watts with it. I wouldn't go to the maximum, but 20 watts should be no problem. So the design, and especially the choice of the microcontrollers, which has a relatively good internal accuracy of its oscillator and its bandgap voltage, etc., that looks quite promising. Of course, the accuracy that they are stating here on the eBay ad is in the range of 1% or so. That's certainly not the case, but we'll just make a simple try. So until now we only had the one disadvantage, that was it does not have a 4-wire Kelvin connection to the load. So only the amps display and all values that are derived directly from the amps can be expected as accurate. The second thing is it is advertised as handling loads from only 3 volts upward. So my purpose to use this thing with single 1.5 volt cells to test their capacity, that sorely will not be met. We will try it out, but I have no big hope about that. And the maximum voltage is somewhere in the range of 20 volts. So this is mainly designed apparently as a USB charger tester and USB power tank tester, not so much as a battery tester. It can, with 3 volts minimum voltage, it can of course test lithium cells and here lead acid batteries like this 6 volt one here, but so really probably not 1.5 volt cells. So let's connect first of all here this AA rechargeable and let's see what we get on the display. So I've connected it in parallel with my multimeter to this single AA cell, and you can see the true voltage is 1.3 volts around it, and the displayed voltage with a resolution of 10 millivolts is 1.33. So that's around 2% off. So that's quite okay. We can live with that. But if we turn on now the potentiometers for the current, nothing happens. So it's really true. This thing works apparently only from 3 volts upward. So no use for me, but as we have it lying around, we'll just test the accuracy with a lead acid battery with 6 volt and see how accurate current and amp hour values are. So now I've connected the 6 volt lead acid battery. One multimeter as a current monitor, the other one measures the voltage, and the next disadvantage is here when I set both potentiometers to minimum, the minimum settable current is somewhere between, depending on, it doesn't go right down to 0, so it's sometimes 40 milliamps, sometimes 60 milliamps. So it's not possible to use really low discharge currents. And next thing you see is now the voltage differential, even at 60 millivolts, has become larger simply because this thing doesn't measure the voltage with the 4-wire Kelvin connection, but on board, and we of course have the voltage drops here over the cables. And now let's turn on the right potentiometer, the fine potentiometer, and let's try to set this to 100 milliamps, or let's say 300. So that's not enough. I have to use the coarse potentiometer. And let's see how accurate the setting is. So we're displayed 300 milliamps, true value is 310, so again a 3% offset. We even could live with that. But now you can see the voltage differential between displayed and true voltage at the battery. It becomes larger and larger. 5.87 volts displayed, 6.22 volts is the true voltage. So voltage, wattage and watt hours, the larger the current becomes, or the larger the voltage drop by the current over the cable becomes, the less accurate this becomes. Well, it doesn't interest me because I only want to know amp hours, and for that purpose let's reset this, start the timer. It's really awkward here to work this way on camera. So I did reset it, start the timer, and now let's wait. And because the time is also displayed here running, we can compare it even after 1 or 2 minutes. But we'll wait a little bit longer because there was a 2-second delay between pressing the reset button and starting the stopwatch. So I'll be back in a few minutes. So after 20 minutes we should arrive at exactly 0.1 amp hours, because 20 minutes is a third of an hour, and a third of 0.3 amps gives us exactly 0.1 amp hours. And at the moment we're 0.100, and in the next few seconds, so this is bang on, astonishingly, and the time is only 2 seconds off. So the timing is very correct. The only difference we have is this 3% error in the current, but a 3% error in total is totally sufficient. So concerning the accuracy, this thing is really usable, at least when it comes to the amp hours and the amps. Forget about the voltage, the wattage and the watt hours. At least when you have a large voltage drop on your cables, but the amp hour rating or measurement is quite accurate. I'm quite surprised. This thing seems, concerning the accuracy, a lot more better designed than this little thing here, probably due to the accuracy of the internal timer and the ADC and the band gap reference of the used microcontroller. So quite okay, but for my purpose it cannot measure single cells. It doesn't have Kelvin-connections, it doesn't go down to 0 volts, and of course it has no turn off voltage or cutoff voltage, so the load is constantly present until your battery is drained if you don't sit beside it and watch out. And that's of course a bad thing for batteries. That was also better with this thing, because you could set a cutoff voltage and then the MOSFET turned off, so your battery wasn't drained totally, which really results in a damage. But for its purpose, measuring power banks and USB chargers, this thing is okay. So let's go over to the big 120 watt constant current load. So let's see how good this thing works. As you can see, I've connected now again the rechargeable AA cell, and first of all we already get a differential of around 3% in the voltage measurement. Now that's okay, we can live with that. And now let's turn up the current and see what is the minimum current this delivers and how accurate is it. So, and there's a strange thing, when I turn the fine pot on the first part of the rotation, nothing happens, and then it sets in, and you can see we have quite a big offset. Displayed is 30 milliamps and true is 44 milliamps, so this is 15% off. So obviously this thing is not useful for measuring with low discharge currents. So let's see how finely we can crank this up. So apparently it looks like, well, it's 10 or 20 milliamps step size. And let's also go to 300 milliamps, as good as I can set it, and see how accurate the reading is there. So we're displaying 0.3 amps, and in fact we have 0.31 amps. That is on the one side 3% off, or in absolute values 10 milliamps off. So it's jumping around a little bit between 0.3 and 0.32. So that seems to be the resolution of the ADC. 20 milliamps is apparently the ADC resolution. And because it jumps around, it could even be that the mean value, when it sometimes measures 0.3 and sometimes 0.32, that the mean value could in fact be quite near to 0.31. So at medium current, this thing, I try to set it to more or less exactly. Now you can see we get 0.28 displayed, but it's nearly 0.3, so again 20 milliamps off. And let me try to tweak it to more or less exactly. So the fine pot is not so fine as I would need it. So that shall be enough. But the clock is not running. Why is the clock not running? It already displays 10 milliamp hours measured, but the clock is not running. I don't understand that. Did I do something wrong? Or it might be that the clock is not showing seconds, but minutes. Let's see if we can reset it. Okay, the reset works. So we'll again measure 20 minutes and see what happens. So I'll reset it and start the clock. So time is nearly up. One thing has happened in between. You can see the current is slightly different. That's due to that the current is set completely in an analog way. So the potentiometers are not scanned by an ADC from the microcontroller, and then the current is set by a DEC or something like that. That's completely analog, and so not 100% stable, and we should get now 20 minutes exactly 0.1 amp hours. So the resolution here is 1 digit less than in the smaller constant current load. We get 0.10 amp hours. That's quite okay. So let's say that this thing has an accuracy in the range of 3 to perhaps 5%, which would be sufficient. But there are a few things I don't like. You can't set very low currents. So the potentiometer here, you can see I turn it and nothing happens. And the resolution in the very low, in the tenths of milliamps, is not good enough for a precise measurement of small batteries. Of course, if we take beefier ones like here, this 1.2 amp hour lead acid cell, that would be no problem. But for my purpose, again, we have not a 4-terminal measurement. You can see already now here with 30 milliamps we have a differential. And look at that. So the watt and watt hours measurement is completely out of range. Strangely, the timer didn't start, although it was measuring and displaying the correct result. But I don't know why the timer is not running, and apparently also not in the other display mode. So I don't know if there is a special setting for what do I do with the temperature. I don't need that. And by the way, if we ramp up the current to a certain value, then the fan will automatically start. You can see here at 0.8 amps. So that was the reason why it was not running at very low wattages. The fan is simply not needed. And it has no cutoff voltage. I've already constructed a little extra circuit here to add this feature with 3 pre-programmed cutoff voltages. Perhaps if you're interested, I will add in another video show you or demonstrate you the circuitry. Still have to write the software for the little ATtiny 25. So I could retrofit the cutoff with a relay extra, but it's really not good for measuring low currents. The resolution simply is not good enough. The potentiometer setting is not what it should be in the fine range here, and well, this thing could halfway work for my purposes, but it's not the real deal. I'm still waiting for one that seems very promising, which is all the features that I want. But I'm waiting now for 3 months. The first one got obviously lost in the mail, so I ordered another one again during Chinese holiday, and it's still somewhere between Shenzhen and Germany. So that was it for today. I'm not very happy with the results. So for other purposes, these two constant current loads are certainly okay. So that was it. Thanks for watching. Until next time, bye from Roger, bye from Kanka Labs.